periodic table, the elements are arranged in increasing order of their atomic numbers. Hydrogen, with atomic number 1, is the first element and has the simplest atomic structure of all the elements. The nucleus of hydrogen atom contains 1 proton but no neutrons. It has only 1 electron in the K shell, which is the outermost orbit of the atom. It belongs to the first group and the first period of the periodic table. Since it belongs to the first group, it is expected that the properties of hydrogen should be similar to those of the other members of the group. But that is not the case. The position of hydrogen has always been a question of debate since the time Mendeleev presented his periodic table. This is mainly because some properties of hydrogen resemble those of the alkali metals in group 1. Others are similar to those of halogens in group 7. Hence, we may conclude that hydrogen shows a dual nature. Now let's see the similarities between hydrogen and alkali metals. Electronic configuration. Like hydrogen, alkali metal elements have only 1 electron in their outermost orbits. For example, hydrogen with atomic number 1 has the electron configuration of 1. Lithium with atomic number 3 has the electron configuration of 2. 1. Sodium with atomic number 11 has the electron configuration of 2, 8, 1. Potassium with atomic number 19 has the electron configuration of 2, 8, 8, 1. Rubidium with atomic number 37 has the electron configuration of 2, 8, 18, 8, 1. Cesium with atomic number 55 has the electron configuration of 2, 8, 18, 18, 8, 1. Valence electrons. All the elements have 1 electron in their valence shell. Valency. All alkali metals, including hydrogen, have a valency of 1. Burning. Alkali metals burn vigorously when heated in oxygen to form different types of oxides, depending upon the nature of the element. Hydrogen does the same. For example, hydrogen burns in oxygen to form water. Lithium forms a monoxide. Sodium forms a peroxide. Potassium, rubidium and cesium form superoxides. With the general formula MO2, where M stands for the metal. Alkali metals are very reactive and therefore tarnish quickly. Wondering what causes such a quick tarnish? The tarnish is a result of exposure to air leading to the formation of oxides, then hydroxides, and finally carbonates on their surface. Due to their reactive property, Alkali metals are always stored under kerosene. Combination with non-metals. Hydrogen and other alkali metals also react with non-metals such as oxygen, sulfur, and chlorine. Hydrogen forms water, hydrogen sulfide, and hydrogen chloride. Whereas alkali metals form their respective oxides, sulfides, and chlorides. Ion formation. Though the hydrogen ion H+ is known, hydrogen has a tendency to pair with an electron to form a covalent bond. With the help of these covalent bonds, hydrogen and alkali metals form cations. That is, positive ions through the loss of one electron. For example, in lithium. Hence, all these elements have an electropositive character. Reducing power. Alkali metals and hydrogen act as reducing agents. That is, they remove the oxygen from other molecules, forming oxides of their own in the process. Now let's see the similarities between hydrogen and the halogens. Hydrogen is a gas, just like the halogens. Halogens and hydrogen are non-metals. Both have a valency of 1. Both exist in the form of diatomic molecules. For example, hydrogen and chlorine. Both hydrogen and the halogens show the tendency to form anions. Thus, because of the anomalous behavior of hydrogen, it is difficult to assign any definite position to it in the periodic table. The credit for discovering hydrogen goes to the British scientist Henry Cavendish. He obtained it by the action of dilute sulfuric acid on metals and described it as inflammable air. However, later, when it was found that it was a constituent of water, Lavoisier renamed it as hydrogen, which means water former in Greek. Hydrogen is the most abundant element in the universe. It is found profusely not only in the atmosphere of the stars, but also of planets, including Earth. It is the 9th element in the order of abundance in the Earth's crust. In the combined state, hydrogen is available in water in abundance and it is 11.1% by weight. It is also available in other inorganic and organic forms like coal, petroleum, clay, and plant and animal tissues. Acids, alkalis, all hydrocarbons and proteins also contain hydrogen in the combined state. Did you know that sugar, starch, and fats also contain carbon?